Good afternoon, all. Thank you so much for joining our presentation on silicone seal heads today. I'm Brenda Denny, United Silicone's product manager overseeing our heat seal product lines. Joining me off camera is Jim Knutson. Jim is Business Development Manager for ISM, Industrial Specialties Manufacturing. ISM is United Silicone's partner and our master distributor for our heat seal products worldwide, not just North America, but we do distribute, we do manufacture and ship worldwide. I know many of our participants today are joining us from Europe as well. Again, thank you for joining. What we'll do today is going to go through a brief introduction and presentation of silicone seal heads. We're going to watch a video, and then afterwards, Jim and I, we've scheduled time, lots of time actually, to go through Q&A, questions and answers. With us not being in person in Chicago this week, we're missing out a bit on that dialogue, the conversational piece that's so important. So please use the Q&A to do that. Even though we're virtual, the idea that we have Q&A that allows us to interact with you and understand your projects and maybe some of the aha moments that we've triggered, that I've triggered in our conversation and video today. So with that, we'll go ahead and get started. Silicone seal heads. Many of you may not have utilized them, might not be familiar with them. Traditionally, rigid packaging, tray and cup sealing is very common with metal seal heads. I'm going to use some hand gestures here and use some terminology for top and bottom. It's very common traditional method of rigid packaging, rigid sealing for trays and cups is to use a metal head on what I'll call on top, a metal head against the heat, if you will, and a compliant surface or a silicone surface as a support underneath the flange or the lip of your cup or tray. What we're going to discuss today or present today is an option to that. The idea that we'll be switching, instead of doing metal on top and metal or compliant on the bottom, we're going to flip it upside down. We're going to do silicone against that heater and a metal or a rigid support underneath. So before I steal too much thunder on the video, let's go ahead and we're going to show a video of a case study that actually shows where the choice between going from metal to silicone came into play. So we'll go ahead with the video. Jim, if you could start us off, we'll be back in a moment to discuss it. Seal heads.
United Silicone partnered with a major food brand and their various vendors to achieve quality seals. Peelable, consistent, repeatable, no leakers. Challenges and obstacles. 1. 2 million out-of-spec cups. 2. Defined go-to-market date with minimal time remaining to launch, 4 to 6 weeks. The first call came from the cup manufacturer. Their dilemma? They had molded 2 million cups out of spec. The second call came from the contract packer. They now had 2 million cups they couldn't seal reliably, using existing machine formats and tools, metal seal heads. The third call came from the brand owner themselves, desperate for a solution to save their market launch. Initial machine and tool format utilized metal seal heads, 4 across and 33 anvils or nest supports. This approach resulted in 2 finished part spectrums. 1. Weak/poor seals with significant scrap rates, leakers. Or 2. Overseals/welding of film, not peelable. United Silicone's revised approach replaced the existing metal heads with thermally conductive silicone seal heads. The new compliant head design achieved a perfect seal against the variation in wall thickness with the cup's flange. Of note, machine settings for temperature were adjusted up 100 degrees Fahrenheit to achieve and maintain the same temp at the silicone head face as the initial metal head. This temperature adjustment enabled us to maintain original cycle times, resulting in no loss in production throughput. Silicone seal head changeover was addressed with United Silicone's magnetic mounting systems. Goals and objectives. 1. Minimal to no effect on production yields. 2. Limited maintenance labor. Silicone seal head released underhead engaging design mechanism to relieve magnetic hold. Using heat-resistant gloves, the technician replaces existing seal head with new head preheated offline staged for changeover. Literally snaps the new silicone seal head into place and restarts production line. No muss, no fuss. This team approach, including United Silicone's participation as vendor partner, turned 2 million out-of-spec cups into an on-time market launch with high-quality products and brand reputation intact. What do leakers cost you? If you've been involved with a market launch or dealt with high scrap rates specific to your sealing application, there are alternative tooling options available. Contact ISM, United Silicone's master distributor, to initiate a project discussion. We welcome the chance to partner with you.
Welcome back. So any aha moments, anyone scratching their head saying, wow, I've been there, done that, or some semblance of that anyway, where maybe not as involved as what this brand study did, but the idea that possibly a narrow process window on your side where you believe maybe the silicone seal head could be an option for you, something to make that process window bigger. To recap, so 2 million cups, my favorite line, usually at Christmas time actually, trash to treasure. The idea those 2 million cups were garbage. And not only the idea of the cost of them, the whole market launched. So how did we turn them to treasure? And the idea of the silicone seal heads in this case saved the day. So some of the things to consider when looking at the silicone seal heads as the alternative, what we considered here in the case study, is we went back to the idea, the parameters, the theory of heat seal. We have time, temperature, and pressure. Any of the tools you select for heat sealing, for packaging, always need to be able to facilitate time, temperature, and pressure. So again, we talk about pressure. The idea that the silicone provided the pressure point, the contact, the sealability on these cups that the metal heads couldn't. What we didn't go into the case study is what was happening with the metal heads because the cups were truly out of spec. That flange did not have a consistent wall thickness. So what was happening is they were overcompensating with the metal head, and it was actually welding the film, melting the plastic and welding the film, and couldn't peel it. How many of you, how many of us have ever had that happen, and all of a sudden we have an explosion of product in our lap because we couldn't get the seal off? So it's one thing that it could seal, but it oversealed. Didn't seal, it welded. The silicone seal head took care of that, having that compliance, the flexibility to make up for the inconsistencies in that flange or the wall thickness. This piece here, the silicone solved that. So, okay, so now we have the solution for the pressure and the sealing, but we still have to have throughput. We still have production now to worry about. And as we talked about in the video, the other parameter of heat sealing now is temperature. The silicone, although it is made, United Silicone's materials are engineered for heat tolerance as well as thermal conductivity to actually transfer the heat. It's still silicone. It's not going to transfer the heat the way metal does. So in the case study, we talked about the idea that we needed to bump up the machine setting, that temperature at machine setting, about 100 degrees Fahrenheit in order to achieve that same surface temperature at the silicone, at the point rubber meets the road, at the point that the silicone seal head came in contact with the cup. So time, temperature, pressure. Time, the idea of the dwell time, but also in this case, it was the changeover time on the seal heads. Now we've introduced a consumable. that die, that seal head, is not going to last as long as the metal. So the magnetic, and I'm going to do a quick show and tell before we go to Q&A, but what we talked about was the magnetic seal head. And you can hear it, hopefully our mics are working well, can actually snap it in place. And what you saw, or what was discussed in the case study, that is literally done under the head of the machine. No need to take all of the tools out and reinstall. With a pair of hot gloves, it can truly be done under the machine head. Before we run out of time, I want to leave it open to some Q&A. So with that, Jim, what kind of questions and answers have we received today?
One of the questions asked of us is, do you recommend silicone seal heads and silicone nest supports?
Generally speaking, no. And the reason for that is, again, back to the theory of heat sealing, time, temperature, pressure. So in this particular case, it's pressure. We want to make certain that we can achieve a pressure point. If we have two compliant surfaces working against each other, or together in this case, if we have the silicone head together with a compliant surface underneath, they're going to struggle against each other in order to make that pressure point. So with that in mind, we, United Silicone, recommends always utilizing a rigid tool in conjunction with a flexible tool. So in this case, the idea of the silicone seal head with a rigid support, or in the traditional sense, the rigid support with the compliant support.
Okay, thank you. Your silicone is tolerant to what temperatures?
United Silicone's material is tolerant to 550 Fahrenheit, which equates to about 288 C. The thing to consider with that, in that heat tolerance is important. Not all silicone materials, not all compliant materials are created equal. Some materials, such as urethane, are not heat tolerant. They start to break down about that 160 F. So the idea that the 550 F, and that we do need to run hotter, again, these materials are truly designed for this application.
Okay, thank you. What is durometer and what does it mean?
Durometer, when we're talking about compliant materials, is the hardness of the silicone itself. So even though it's compliant, it has a hardness to it. As a point of reference, a pencil eraser, and I'm going to do my little top pencil eraser here. Pencil eraser measures about a 60 durometer on the short A scale. When we're talking about the silicone seal heads, the harder materials transfer heat better. So with a silicone seal head, we generally start at an 80 durometer, again, using 60 durometer as a baseline.
Okay, thank you. What does thermally conductive mean?
Thermally conductive, again, it's that ability to transfer heat, or to conduct it out of, in this case, out of the seal head, to actually transfer it from the silicone through the film to your part to create that seal, as opposed to an insulator, something that wants to hold it inside.
Okay, good. Thank you.
I think we're getting the word that we need to go into wrap-up mode. Again, your Q&A, the questions and answers, are very important for the dialogue. Please continue with those. Jim and I will come back to them. And I'm sorry, I lost my train of thought. But with that, thank you again for joining us. It's very important that we stay in touch. And we talked a bit about part supports. Please join our live demo on part supports and anvils tomorrow afternoon, Tuesday, November 10th at 2:15 Central Time. Again, thank you all.